Hi, my name is Tom Wason. I'm joined today by my colleague Renee Rubalcaba. And today we're going to talk about using the ArcGIS API for JavaScript in applications that are built with Webpack and React. Renee works on the JavaScript API team and many others, and I work on the ArcGIS Hub. But both of us have worked on these new ArcGIS API documentation guide pages for working with frameworks. And of course, we've got a page on that documentation for working with React. But today we're going to take a deep dive into React and go beyond what we have there on those documentation pages. So pulling way out, looking at the central philosophy of React, is that your UI should be a function of state. The central philosophy of the ArcGIS API for JavaScript is give us an item ID and a DOM node, and we'll give you the world, literally. So how do we get these two to work with each other and communicate with each other? Well, let's start with what we know, and that's on the ArcGIS API side. Typically, you're going to start by creating a map. You pass in some initial properties like a base map or a portal item. Then you're going to create a view, map view or scene view, and that view takes a reference to the map as well as a container, some kind of DOM node that it's going to display the map in, and any other additional properties like center and zoom. Well, the first question is, where do we get that container? Because the way that React works is that it might start with some global state like a store, and then you're going to render a tree of components into some root level DOM node. And typically that root level DOM node is the only DOM node in your index.html file. And these components each take that state, gets passed down from component to component. Each one might have its own internal state, and it's going to render out some DOM. Well, actually it renders out virtual DOM that React will reconcile into actual DOM nodes. But the key idea here is that those components are the link between state and DOM in React, which is why the way we handle this integration is to use a component as a bridge between the worlds of React and the worlds of ArcGIS. So looking at that tree again on the left, the component tree, at some point in that tree, you're going to want to render a map. And so we'll create a map component. And this map component will work like any other component in React. It'll take in props, may or may not have its own state. It's going to render, and then we're going to get a reference to a DOM node that it rendered. And that is where we can now create a new map and a new view. And the key thing here is that container will come from the ref. And we'll take a look at that more closely in a bit. But this is sort of the simplest level of integration between the two. Because what happens here when you create this map and you create this view, it kicks up a whole flurry of activities, like the map's going to do a bunch of asynchronous fetching of data. It kind of becomes its own state store, managing all the layers and everything. The view, of course, has its own state, and the view starts listening for user interactions. And your React application can remain blissfully ignorant of all of that if it doesn't need to know about any of that. The map component can kind of be a black box for React. But sometimes you do need to notify React when state changes happen over here in ArcGIS land. And so you can take your map component and sort of level it up to be a two-way communication bridge. And how this works is it will register some callbacks as handlers for click events or events on the view or property watches. And those callbacks will then update state, and they can either update the component's own state or maybe update state further up the tree of components depending on wherever the callback originated. So that is the high level kind of view that shows the flow of state. It can be one way or two way between React and ArcGIS, but the key thing is it is unidirectional. It starts on React, goes through your bridge component into ArcGIS, and optionally back, and then looping around again if needed. So let's dive into that component and see how it works. The first thing is, how do we get a reference to that DOM node? Well, React has a notion of refs, And these are typically used to get hold of DOM nodes. And we're going to look at the class-based syntax first. We'll talk about function components in a bit. But in the constructor, you call createRef, and then when you render, you use a ref attribute to assign the value of that element that will be rendered out to the ref. After the component renders, there is a lifecycle method called component-did-mount, and this is our opportunity to create the map in view, just like you would with any, this kind of code comes straight from the ArcGIS API samples. The only thing to draw attention to here is the container and how it is coming from the current value of the map ref. Another thing to see here is that we've got this dot view. We're assigning a reference of that view to the instance of the class. And the reason that we do that is so that we can access it in other lifecycle methods. For example, when the component will unmount, this is called right before the component is destroyed, and this is where we want to do any cleanup. This is where you would also clean up any callbacks if you had registered them. So that's the full sort of minimum viable integration between using a class-based component. But you may know that the React community is heavily influenced by functional programming ideas, and so this idea of a class-based components doesn't sit well with some people, and so you've been able to create simple components that are just functions. For example, this silly name tag component is just a function that takes in a prop name and renders it in a paragraph tag element. And this is really fast and easy to write. However, these do have limitations. There's no way to create refs from these functional components. There's no way to access lifecycle methods, and there's no state. And so up until about a year ago, there really hasn't been a way to use these to do something as complicated as render a map. But a little over a year ago, React introduced a new set of APIs called hooks, and they allow you to write functional components that use refs or lifecycle methods or state. And what hooks are, React has a few built-in ones. They're functions that you can call from your functional component. And these functions have to follow certain rules. One of them is that they all have to start with the word use. And there are other rules that you can see more about in the React documentation. But these are the ones that we're concerned with when we want to use hooks to create a map in a function component. So let's take a look at what that looks like. So as you can imagine, we're going to start with useRef. So this is emulating the same behavior we had in our class-based component here with a function component. So the first thing we do is that we pull in the useRef function from React, and we create a ref, and the same way we did before, we assign it using the ref attribute when the div is rendered. That's pretty straightforward and easy to understand. Things get a little more complicated when we try and tap into those lifecycle methods. The hook we use for this is called useEffect, and it effectively can replace component-did-mount, component-did-update, component-will-unmount. And let's take a look at what that looks like. So this is inside the body of our same function component. There's our call to use ref at the beginning, the map ref. And right beneath that, we'll add this call to useEffect. And that takes a callback that's going to be executed later on after the component renders. And this is where we create our map and our view just like we did before. And the same thing, we're using the map ref, the current value of the map ref as the view's container. This is just like we had seen before. However, in this case, we're going to do also our cleanup in this same effect. And effects have this way of handling cleanup of anything that they create, and that is you can return a cleanup function. So in this case, we're going to destroy the map view when the effect is cleaned up. And effects also take a second argument, and this is where people often get tripped up. But the second argument is a set of either props or state values that the hook depends on, and whenever those change, the hook will be rerun. Well, in this case, we want to emulate that the behavior of component did mount, component will unmount. And so in this case, what we do is we pass an empty array. If you pass nothing here, this will happen. This will be executed every time, and the map will be destroyed and recreated anytime the component re-renders. So we definitely don't want to do that. So this is important right here. We want to do this to emulate that component did mount behavior. Now, we talked about another hook called useState, and this is just how you manage local state within the component. It has the API is a little awkward at first, but you get used to it real quickly. You call useState with the initial value you want to pass the state, and it returns an array. And that array, the first element is essentially the current value of the state, and the second element is a function you can use to set that. So this is something that, you know, like for example, this set ready we might call in a views when callback to indicate that the map is loaded if we needed to hide or show a loading spin or something like that. Now, one trick that you can use with state is to hold a reference of the view. And the reason you would want to do this is if you needed to say bind view or map properties to your components, props, or states. So let's take a look at how this works. So here we're using we're going to call useState to hold a reference to the view. We're going to initialize it with null. And then later in useEffect, like that effect that we just showed where we create the view, we could set the map view, we could set the view equal to our instance of the view. Then we could add a second effect that will wait for that view to be created, and then it will update properties on that view. And here we use that second argument to useEffect. And it's saying that this effect depends not only on the view, but this other zoom. Let's say this component takes zoom as a property, the zoom level, right? And so anytime the zoom changes, maybe it's bound to a drop-down that exists in another component, this effect will be rerun. And we can update the view, the zoom of the view, assuming it's been loaded. Okay, I know that sounds like a lot, but to look back on what we've done, we've created a map using a ref to DOM. We're only destroying that map view when we're unmounting, and we can relay changes in the component state or prop to the map and view. So this is that one-way communication from React to ArcGIS. But what happens if we need to relay changes or events from the land of ArcGIS to React? We talked about before using callbacks. What does that look like? Well, it looks a lot like how we use an effect to watch for changes in a prop or state. So in this case, we would create another effect, and again, it would only be executed if the view had been created. And this effect is going to create a handle that is going to hold on to a handle that is created when we register like a click event. And then it's going to return that cleanup function, and it's going to just call remove on that handle. And this way, we'll be able to clean up after itself. So this is sort of very similar to how we watch props and state. We can also watch a callback that was created either somewhere upstream or in the component itself. We'll show a demo of how to work with hooks later, and it'll be a little bit easier than all of that. But in the meantime, the part that we want to understand here is that the component is key to integrating ArcGIS API with React. It's going to act as the bridge between these two worlds. We can use a ref to get the views container, and we can send props and state over from React to the map and view properties, and we can also send changes back from ArcGIS to React. Now, there's a lot more going on in React than just components, and I'm going to hand it over to Renee here in a second to talk to you about some of the other modern React APIs that you can use when working with the ArcGIS API for JavaScript. But everything that we've talked about up until this point has been is stuff that you can see, again, in that React page, in the React guide, in our framework guides on the ArcGIS API for JavaScript documentation. So we have a section on hooks, and we have a section on how to use a class, and they show you everything that we just talked about here. But right now, we're going to hand it over to Renee.
Hey, thanks, Tom. Okay, so I'm going to talk a little bit more about some of the other React APIs that are available and how you can use them with the JavaScript API. So one of the things in React that has always been something that comes up quite a bit when people build their apps is how to manage state. Because remember, React is not a framework. React is a UI library. It just happens to be a very powerful and very popular UI library. So when React was first released, they provided this kind of documentation on how to use something called Flux, which is a pattern, really, on how to manage state inside React applications, which actually works pretty great. I'm still a fan of using the Flux pattern for smaller applications because you pretty much just are going to be using set state for class-based components or the useState hook for hook-based components, right? And it's a very simple way to kind of update state inside your application. If you need something more powerful, you might jump in using something like Redux, which is very powerful, but does kind of come with having to create quite a bit of boilerplate. However, like I said, if your application calls for it, then you might need it. The same goes for MobX, and MobX is pretty interesting because it actually provides an observable pattern to watch for changes to happen and update state and everything, which coming from using the JavaScript API and the way our accessors work is it's a pretty neat way to go. I kind of like MobX. However, you may not need any of them. React now, the latest versions of React, come with a context API. Now, technically, the context API has been there for a while. It just wasn't publicly docked, and it's something that libraries that were more deeply integrated with React would use, routing libraries and so on. But now it's a full-blown API in React that you can take advantage of, and it's very powerful and allows you to inject state wherever you need it. Now, the way you do this is by using a hook, of course, called useContext. Now, the useContext hook is pretty cool because in this sample here, what you might do is you might have a context that's going to manage the theme of your app, and you'll pull the theme from useContext and then apply that theme somewhere. And then in another part of your application, you would have a way to update the state on that context, and it would just get propagated wherever the useContext hook is being used inside your app, which is really neat, right? I mean, there's not much of a need for dispatching messages if you don't want to inside of your application using Redux. There's still a use reducer hook that kind of works very similar to how Redux would work. It's pretty interesting, but I really like working with the Context API. And I'll show a bit more of the Context API in the sample in a little bit. But one of the key things with working with React, and Tom kind of touched on this as well, is being able to modularize the API usage. Basically, run the API in kind of its own little sandbox environment of your app where the UI components of your application don't necessarily depend directly on the JavaScript API, but they're going to depend on other modules in your application that do have dependencies on the API. And this lets you do some other really cool things with it, right? So one of the ideas here you want to do is you want to separate the content from navigation. This is how patterns in progressive web apps kind of work, right? The content for the application itself is kind of handled in a completely different, well, I don't want to say different thread. It's handled completely differently than how you might manage the UI. The UI is going to do its thing, And then the data loading or business logic is going to do its own thing. How you pull the content in, the content in. It's easier to stub the JavaScript API in your test, so you're not necessarily going to write mocks or stubs for something like Esri map. You're just going to go ahead and mock maybe a function that's going to interact with the map and do it that way. That way you can test your components much easier, especially if you're using something like Jest. It just becomes a lot of writing these little mock classes that Jest can go ahead and run and do all its testing in. So here I've got a little function that I'm going to export from a helper module, and it's an initialize function. It's going to take an element, and then it's going to take a map view I already have and apply the container to that element. Then it's going to go ahead and wait for the view to be done, and then something's going to happen with it, right? The map stuff is going to happen. I'll add widgets, and I'll do other really cool things with it. Then you want to use the context inside your component. I'm sorry, yeah, using your context component. So I have a useEffect hook here. And what I'm going to do is, and this can go inside, like I said, your context or the component itself. I'll have this useEffect hook running. I only want it to run the first time because I don't really care about this rerunning when the properties change in this particular case. I just want to go ahead and import my helper module and then run the initialize method on the helper module that's going to go and pass the element that is going to reference my particular component, right? And we've seen this already. Tom showed this kind of use ref pattern already, so it should be already pretty familiar to you. Questions are, why do you want to lazy load the API? And this is pretty important when you're doing your Webpack builds, because what you want to do is you want to minimize the number of JavaScript files that are going to get loaded when you first load your app. And the JavaScript API is actually pretty big because we have, you deal with a web map. When we load the web map, we need to determine, are you using a CSV layer, web tile layers, feature layer, or what have you, and then we have to dynamically load those modules and stuff. So by lazy loading the parts of the API until you actually need it, you actually create more bundles, and then you can load those resources only when you don't need to worry about dealing with all those resources up front. This leads to faster initial loads. So you get the page going faster, the user gets interaction faster, and everybody's happy. Okay, so Suspense. So this kind of goes hand in hand with the lazy loading stuff that we've already talked about. Let me talk about this slide here, the hold your suspense, right? So Suspense is, and I'll show you the documentation actually, because documentation is fun. Big red note, and experimental features that are not yet available in a stable release. So Suspense is still, I think the API is just about settled for Suspense, but there's still some work going on under the hood, so it might not be something you want to start using in production just yet, but it is there to let you do some really cool things. And this kind of goes hand in hand with the lazy loading part, and it works pretty well with stuff like the like routing, which is pretty cool. So in this case here, what I would do is I have a web map view component. That component may do some lazy loading of the JavaScript API, modules, what have you. I'm going to wrap it in this lazy function that I'm going to pull from React. Then there's a Suspense wrapper or component, you could say, that I then wrap this web map view in, which basically means it's going to go ahead and lazy load this component on the page. It'll dynamically load those modules and create more bundles. And the fallback is going to be this little placeholder component here that's just going to have loading and 3 dots displayed on the page until my web map view component has done all its work it needs to do to be able to display on the page. So once it's loaded, then that loading indicator will go away and I'll get my web map, right? That's kind of how Suspense works. And like I said, it's really useful in modular apps. It's really useful in conjunction with routing. So it's something that you can take to really optimize how your apps function. So let me go ahead and show you a sample application. This is a example app, this is an open source app called Nearby JavaScript. You can find the documentation page on the developer site. And it comes in a couple flavors. There's an Android version and there's a JavaScript version. We have links here that go to the source code for the JavaScript version, which is on GitHub. And we have that here. Make that a little bigger for you. So you have the source code available to you. This application is built as a progressive web app. It is, has some features for geocoding and location. You can go ahead and run this yourself. It has authentication built into it. It really is a full-blown app that you can use. Now, what you'll notice here is that when I first load this application, there's no map, right? So I'm using routing inside this application, and when I first load it, it takes like 13 JavaScript files. There's an extra one here because my React Dev tools are currently on, but it's okay. And then as I go and click on one of these, it's going to go ahead and load the map, and now I'm lazy loading a few more files so that I can actually load the API and then display this location on the map, which is really cool. So how does this code look like? Now I'll just quickly go over some of this. So I've got some helpers in here. I've got a wrapper here for reach router. I'm pulling in Suspense from React. And I'm going to go ahead and wrap this. This location here is for the routing part. And here's my app provider, which goes hand in hand with my context API that I'm using. And then here's the Suspense part. Now I have my Suspense. It's going to lazy load the routed pages, part of my API. So I have the layout, which is the list that we saw earlier, as well as the web map. I'm sorry, the list that we had, as well as the web map here. I'm wrapping the router. I've got some media query stuff going on. But all of this is going to get lazy loaded inside my application. The fallback is just going to be a little placeholder kind of stuff so that people see something when the application loads, which is really kind of cool. Now I'm going to jump into one of these components real quick, which is going to be the web map view. And the web map view is going to go ahead and use a custom use web map hook that I've built in here. That's just going to go and have a function called set container. So this is going to update the state inside that hook for the container. And if we look at this inside of our context, we have a single context that we're going to use. And this is part of the context API. So the context is actually going to use all of the hooks that interact with the JavaScript API. So even in here, I'm not directly loading any JavaScript API modules. I'm only going to use hooks that are going to interact with the JavaScript API. So the context API manages all of my state, and then at the very bottom down here, I'm going to go ahead and return the context with the value that's going to contain the state and a function to update that state. And that's how you can work with the context inside your apps. And just very quickly to show you, I think the authentication, we do a quick search for useContext, just so you can see how useContext is used. Here we go. So I'm going to go ahead and pull in my context here. So I have my state and my set state. And then I'm going to go ahead and pull the mode. This is going to be basically, am I on the list page, or am I going to be navigated to the map? And then I do certain things with the application bar at the top based on whether I'm in the list or if I'm on the map view, right? That's how you can implement the context API into your React components to really kind of flesh out the state management for your applications. Now with that, I'll go ahead and hand it back to Tom.
Thanks, Renee. So as Renee mentioned, that application was built with Webpack and using the ArcGIS webpack-plugin, which it's great. It lets you use that familiar import syntax for Esri modules, and is just everything works kind of as you would expect. However, there are a few limitations. Of course, you have to be using Webpack, which is a given for using a Webpack plugin. You have to be using ArcGIS API 4.7 plus, which, you know, we got 4.15 coming out here, so this is really only an issue if you need to be using version 3x of the API for some reason. But finally, you need to be able to configure Webpack, and what I mean by that is not that you need to know how to be able to do it, but you know, popular React tools like Create React App or these sort of I call them micro frameworks like Next.js or Gatsby that sit on top of React all get you up and going really quickly, but they all sort of not only insulate you from having to know how to configure Webpack, but a lot of them actually like sort of proactively try and prevent you from doing it, and they make it very hard to be able to configure Webpack. So if you're in one of these situations, you either need to use version 3x, or the CLI or the tool that you're using prevents access to the Webpack config, or you just don't want to configure Webpack. We do have a solution for you, and it's a little library called Esri-loader. It works with version 3x of the ArcGIS API as well as 4x. It works with any React tool or library. And by the way, it's not just for React. It's not just for Webpack. It works with any other module loader, and it works with any other framework as well. The way you use it is you install Esri-loader the way you would with any other library as a dependency. And then in your application, instead of importing directly from the Esri modules, you instead import a function called load modules from Esri-loader. And load modules then you call with the names of the modules that you need, and it returns an array of those modules. This might look familiar to you if you've been doing ArcGIS API development for a while, as the Dojo require statement, and that's actually what load modules does under the hood. It does some other things though too. It will also by default lazy load the ArcGIS API for JavaScript. So the first time you call load modules, it's going to, if the script tag hasn't been added to the page for the ArcGIS API for JavaScript, it's going to do that. And then the next time you call it, it's going to just go ahead and load the modules, not load the API again. So that's pretty cool. And as Renee said, the reason to do this is just to get that initial load time to be fast. Now, just a little FYI, this does not work with Suspense. You don't need Suspense for this. This just sort of works in a different way. There's a whole bunch of other things that you can do with Esri-loader. You can, as we talked about, you can load version 3x, and you can also use it with the ArcGIS types. So there's additional resources for you on the Esri-loader documentation. I've got links to them here. But load modules is essentially the basic setup that you need. I've also got an additional library that called Esri-loader hooks, which sits on top of Esri-loader, and it provides a couple of additional hooks to make working with hooks easier for you. So we'll take a look at that in a second here. But as you can see, this, for example, this use web map hook here is something that we can pull in from Esri-loader hooks, and that whole, all that work we talked about earlier with having, creating a use ref hook, a couple of useEffect hooks, can all be reduced down to just a couple of lines of code. So we'll take a look at that. But first, we're going to take a look at an application that shows you how you can use Esri-loader to bring the ArcGIS API into an application that was built with Create React App. And this is an example application called Create ArcGIS App. This is something every year for Dev Summit we hold a workshop on how to build a full-fledged application that uses lots of features from the ArcGIS platform, not just the ArcGIS API for JavaScript. And so this is the output of that workshop. At the end of the day, we have this open source application. So the way it works is that you would fill in a search term here in this browser. And it's going to return a list of the items that it found as both a view on a list as well as some graphics on a map here. And all that this does is is a component like we've talked about before, as I showed you in the beginning, that in its component did mount calls load modules, Esri-loader's load modules, to get the map class and graphic class and the class and generate the map. So the code for this is here in my GitHub repository, and it's called Create ArcGIS App is the name of the repository. And similarly, we've got another application called Next ArcGIS App that does the exact same thing. It looks exactly the same, only it is implemented in Next.js. So to take a look at what that looks like, this may look like I'm looking at the other application here, but this is actually the Next. And to show you the advantage of Next.js is that you get server-side rendering. And so here, like we are looking at this Appalachian National Scenic Trail, if we look for that in the source of the page, we can see that this has actually been server-side rendering. So this is something where if you're using a library like this to, like Next.js, to get the high performance of server-side rendering, you can even bring the ArcGIS API for JavaScript into such an application. And you may be wondering about this map here that shows above. That would not have been rendered on the server because we only call that the load modules function in a lifecycle hook that is rendered on the client only. So we can get these great SEO of having these the text of this table rendered on the server, but just render the map when the client loads. So again, looking at the this Next.js app is again in Next ArcGIS app is in my repository here, and you can take a look at how we've called it load modules there to do all that. So finally, as I said, let's take a look at this other library that I created called Esri-loader hooks and some of the hooks that are there. So you install this by saying npm install Esri-loader and Esri-loader hooks. So Esri-loader is a peer dependency of the hooks. And what you get once you do is these set of hooks like use map, use scene, use web map, use events, use graphics. And the simplest one to understand is if you just in a couple lines of code, we can load a web map by calling use web map, and it takes in an item ID. It can also alternatively take in item JSON, like the web map spec, and returns a ref, and you can then apply that ref to the element that you're going to render with your own web map component. Similar one here for web scene, works exactly the same. It just renders a scene view instead of a map view. And so we'll take a quick look at what those look like in action. So here is a demo application that is linked to from the repository. And here is that use web map in action. We passed in the web map ID and it loaded the map here. Same here with web scene. So this is taking in a ID of a web scene and it is rendering that here in the div. And again, just 2 lines of code that handle all that work we talked about earlier when we went through how you would have to, take multiple use ref and use effect hooks to do it on your own with the built-in React hooks. Now, what if you were not working with an item from ArcGIS Online, like a web map or web scene? Well, I've created a use map hook that takes in the map properties just as JSON, like base map or portal item could be passed in here. And you can optionally also pass into any of these hooks properties that you want to set on the view, like the center and zoom. And again, 2 lines of code, and we've created a web map here at this div element that was rendered by React. There's the equivalent one for scene here that, again, it will render a web scene instead of, it will render a scene view instead of a map view. And again, it just takes in the map properties, this time with the ground as a plain old, as a POJO that will be autocast and created to a map. Where things get really interesting is when you can start combining a couple of these hooks together. So in addition to the use scene hooks and the use map hooks that we just talked about, I created hooks to use events and use watches. And if we take that same use scene that we did in our last example there, it also returns a second argument in the array, and that second argument it returns is a reference to the view. And now we can pass that to additional hooks like use event and use watch. So here we say when someone clicks the zoom, we want to execute an on-click callback. Finally, there's similarly, we've got one called useWatch, and so when the zoom property changes on the watch, we're going to call onZoomChange. So here we've set up this demo now to, whenever the zoom changes, to show that down there on the screen, and you can see that React is re-rendering that little bit of text every time we interact with the view. And then also we've got another thing that indicates what the last pointer event was. So as I click on the map here, or as I move it around, or as I leave the view, we can capture all that. So this should hopefully get you to start thinking about how you could start combining a couple of generic hooks like this and start creating your own components really easily. Finally, I've got one more hook called useGraphics that just takes, again, it takes that view and then an array of graphics, again, just as POJOs, and then renders them on the map. So this is replicating that sample page from the ArcGIS API for JavaScript. So in conclusion, I hope you have taken away from this that we here at Esri, of course, we love React, we love Webpack, we use them in a lot of our production applications, and that we have these resources for you online, starting with that framework guide page for React. That kind of does a real shallow introduction on how to use that component as an integration between React and ArcGIS. But there's a lot more to it. You can go real deep on that, as Renee showed you with that, with the Nearby app, and of course you have the full source code of that. And if for whatever reason you're not able to use, and configure Webpack, and you need to use version 3x of JavaScript API, we have some examples out there under my own repo from Esri-loader that point out to different things that you can do inside of other kinds of React applications that maybe were created with something like Create React App or Next.js, and how you can use those libraries and together with the ArcGIS API for JavaScript. Thank you very much.